And the following exercises solve each equation. So we're going to do 95, 103, and 108. So the first idea we want to use here is, since we have an exponential on the left here, and we have this number on the right, we try to get them both exponentials in terms of the same base. So what that means is, if I look at 16, I can write 16 in terms of a base 2. So for this problem, I can get 3x minus 8 equals, and I can call this 2 to the, let's see, 4th or 5th. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that would be 2 to the 4th. So once I have these in terms of the same base, since the bases are the same, I can in a sense disregard those and just take the exponents. If this equation is going to be true, then 3x minus 8 has to equal 4. So this is what's nice about getting both sides of the equation in terms of the same base. So now what I do to solve this equation is I just add 8 to both sides. So this is going to be 3x equals 12, and then divide by 3, and then x is going to equal 4. So there's our answer for that first one, number 95. So now let's try the next one here. So again, the same idea applies here. So this one is 103. Okay, and I'm just going to write it out over here. 2x squared plus 2x equals 1/2. Now again, since I have a base 2 here on the left side, I'm going to try to get the right side in terms of a base 2 as well. Now this is where you get a little fancy here, because this is really 2 to the negative 1 on the right. So this is going to be 2x squared plus 2x, and now we have the bases the same on both sides. So therefore, now since those bases are the same, we can disregard the bases and just take the exponents, because those would have to be equal on both sides as well if we're going to have equality here. So that would be x squared plus 2x equals negative 1. So this exponent must equal that exponent if it's going to be equal. Okay, so here it is. So we're going to have to move the 1 over to the left. So that's going to be x squared plus 2x plus 1. And hopefully you noticed why I did that. And the reason why is because when I see this squared down here, I'm thinking I got to move everything over to the same side to get it in standard form, so that hopefully I can solve this equation by factoring or the quadratic formula. Actually, this one factors really nice. So this is a nice one for us to factor. And this is what it turns out to be. All right, so anytime I see a squared or cubed, anything larger than a degree 1 polynomial, I want to move everything over to the same side. Quadratic formula if I can, or just simple factoring. Or not so simple factoring, but still factoring. Okay, anyways. So then my answer here is going to be x plus 1 equals 0, or x plus 1 equals 0. So we don't really have to do this twice, but I just want to write out exactly what this means, just in case this one was different and you see in a different problem. That's the logic that we're dealing with here. These two things times together equals 0. One of them has to be 0. So then to solve this equation, I just move the 1 over the other side, so x equals negative 1. So there's our answer for this one here. So now let's look at the last problem here, 108. Now for 108 here, we have e to the x squared over e to the third equals e to the 2x. Now one thing to realize here, when I'm dividing with the same bases, that means with my exponents I'm subtracting. So this is really e to the x squared minus 3. And that equals e to the 2x. So what that means is I got these in terms of the same base again, using just my exponent rules. So now from here, since the bases are the same, I can just take those exponents, because those also have to be the same if these equations are going to remain the same. So then I move the 2x to the left side, because again, I have an x squared here. So this is x squared minus 2x, because I have to subtract it over, minus 3 equals 0. And this is also going to factor nice. So this is going to be x minus 3, x plus 1. And I know the signs had to be different here because that's a minus for the 3 there. And then the larger one had to go on the 3 because it's a negative 2. So then when I FOIL that out, you'll see that that works perfectly. So now that means our answer is going to be x minus 3 equals 0. Okay, and I'm going to do the other one in a minute. So this implies x equals 3. The other one is x plus 1 equals 0, which means x equals negative 1. So we actually get two answers for this one. And we get 3 and negative 1. So remember what that means. If I plug in those values, let's say I plug a 3 in for all my x's here, for here and here, it's just simply going to make both sides the same. So it's going to make it equal. Some people say it makes it a true statement. So all of those statements are true, so depending on how you look at it. So there's our answers for those exponential equations.